All right, guys. So we're back to take a look at systems of equations, but this time they're going to be in three variables. So we're going to go ahead and just take a look. It's those same two strategies we talked about, substitution and elimination. So here's my first example. Okay, I did that a little smaller, make that a little bigger. Okay. So here we're going to have three variables. So we're going to need three equations. So I've got 2x plus 3y minus z equals 9. I've got negative 2x minus y plus 2z equals 2. And I've got here x plus y minus 2z equals 3. Okay. Now this is completely arbitrary. It's up to you how you want to solve these, substitution or elimination. You know me, I'm a substitution guy, so I'm always going to go substitution given the choice. All right. So what I'm going to do here is I'm going to solve one of my equations for one of my variables. All right. It's pretty arbitrary which one I pick. When I look at this equation, it looks to me like it'd be pretty easy to get x by itself. So I'm going to go ahead and solve this equation for x. That means it's going to subtract y and add 2z to each side. Okay? So I end up with the equation x equals negative y plus 2z equals 3. So this replaces kind of my last equation. All right? Now what I'm going to do is I'm going to go back to my first two equations and I'm going to replace x. So my first equation here, I've got 2x. I'm going to put 2, big set of parentheses, right? Plus 3y minus z equals 9. So that's the first equation. I just left x out. Now I'm going to plug in negative y plus 2z, right? Plus 3. So it should be plus 3 there. I don't know why it doesn't say that. Plus 3, sorry. Okay. Now I'm going to do the same thing for my second equation here, right? So my second equation, I'm going to go ahead and replace x. So I get negative 2, big set of parentheses, minus y plus 2z equals 2. And that big set of parentheses, I'm going to plug in the same thing. Minus y plus 2z plus 3. All right. Now I'm going to go ahead and distribute. So I'll distribute this 2 up top. So I get negative 2y plus 4z plus 6 plus 3y minus z equals 9. So there's my first equation. I'm going to work with the second equation too, so I'm going to distribute the negative 2. So here I get plus 2y minus 4z minus 6, right, minus y plus 2z equals 2. Now I'm going to clean up both equations. I'm just going to go ahead and combine like terms, right? So negative 2y plus 3y is just y. 4z minus z is 3z, right? And then I'm going to subtract 6 from each side. I get 9 minus 6 is 3. Okay, so that's just this first equation again. Second equation, okay? I've got 2y minus y is just y. Negative 4z plus 2z is negative 2z. And then I'm going to add 6 to each side. So 2 plus 6 is 8. Okay. Now you'll see what I've done is I've reduced this. By solving for x and then substituting it, I've now reduced this to a system of two variables, y and z. So I can solve this however I want. I can now do substitution, I can do elimination, whatever. Like I said, you know me, I'm a substitution guy. So I'm going to go ahead here. I'm going to add 2z to each side. My second equation, I get y equals 8 plus 2z. I'm going to plug that into my first equation here, right? So what I end up with here is 8 plus 2z plus 3z equals 3. Now you can see I've got it down to one variable, one equation, one variable. All right, so I'm going to subtract 8 from each side. I'm going to combine like terms. 2z plus 3z is 5z. And then 3 minus 8 is negative 5. Divide each side by 5, and I find that z equals negative 1. Wow, what a lot of work. All right. But now I can go back and I can plug this in. So I'm just going to go back. I'm going to plug this same thing in here and find out what y equals, right? So y equals 8 plus 2 times negative 1. 2 times negative 1 is negative 2. So I got 8 minus 2, so I get y equals 6. Now I'm going to plug those both in to my equation up here, solve for x. So I'm going to plug in z and y into this equation up here, right? So I get x equals, right? And I've got negative y, which was 6, plus 2 times negative 1, which was z, plus 3. So I get negative 6 minus 2 plus 3. Negative 8 plus 3 is negative 5. So x equals negative 5. Now we're going to write our answer as an ordered triple. It is negative 5 for x, 6 for y, and negative 1 for z, right? So we always write our answer x, y, z for an ordered triple, okay? Now I can plug those back into the original equations, and I definitely should, especially when taking a quiz. It's really easy with a calculator to make sure that they actually work, but you can also trust me because I've seen this one before, all right? So I did that one with substitution. I'm going to show you another example with elimination. All right. So here with elimination, we're now going to solve this system. So this system is 4x minus 2y minus z equals 5. X plus 4y minus z equals negative 1. And 2x minus 2y minus 2z equals negative 2. All right. Now I can go ahead and work with these first two equations, right? You can see right off the bat, if I change the sign of the second equation, those z's eliminate. And I've got two variables, two equations, I'm good to go. But this one, something nice actually kind of happens, right? If you look here, I've got 1x to negative 1z. Here I've got positive 2x to negative 2z. So what I'm actually going to do is I'm going to eliminate two variables at once. This is where elimination is kind of nice. I'm going to multiply this equation by negative 2. All right. So watch what happens here. I get negative 2x minus 8y, right, plus 2z equals 2. Always be very careful with your signs. I'm going to pair that up here with this second equation here, right? So I've got 2x minus 2y minus 2z equals negative 2. Now I'm going to go ahead and I'm going to add these two equations, right? So I'm just doing elimination here. And this is just happy coincidence that this works out where I can eliminate two at once. So negative 2x plus 2x eliminates. Negative 8y plus negative 2y, that's negative 10y. 2z plus negative 2z eliminates. 2 plus negative 2 equals 0. So I get negative 10y equals 0. A lot of students here go, oh, it's no solution. Nah, that's not right. Negative 10y equals 0. There's still a variable here, right? So I divide each side by negative 10, and I find that y equals 0. Okay? Now I can go back up to my top equation, pick whichever one I want, and I can plug y equals 0. Any two equations I want. So I'm going to back up to my first two equations. Doesn't matter. It looks to me like maybe since I used these last two, maybe I'll go ahead and use the first one and the last one. That one looks pretty easy to work with, right? So my first equation, I've got 4x, right? Negative 2 times 0 minus z equals 5. And my last equation, why not? I've got 2x minus 2 times 0 minus 2z equals negative 2. Okay? So here, you can see what's going to happen here. These go away. So it's really just 4x, 2x, negative z, negative 2z. I'm going to go ahead, I'm going to multiply my second equation here by negative 2. Okay, so second equation, I'm just going to multiply it by negative 2. So here, the negative 2, all right. Copy my first equation, I've got 4x minus z equals 5. And my second equation, negative 2 times 2x, negative 4x. Negative 2 times negative 2z plus 4z. Negative 2 times negative 2 equals 4. I'll go ahead, I'll add these two equations together because they have opposite signs and opposites attract, right? So those eliminate. Negative z plus 4z is 3z. 5 plus 4 is 9. Divide each side by 3. I find that z equals 3. So now I know y is 0, z is 3. I can pick any equation I want now and plug in 0 and 3 and find out what x is. Let's go ahead and do that second equation. That one looks easy enough, right? So second equation, I've got here x plus 4, and I know that y is 0. Minus z, which I know is 3, equals negative 1. Okay? 4 times 0 is 0. I get x minus 3 equals negative 1, so I add 3 to each side. I get x equals 2. So here I've got x equals 2, y equals 0, z equals 3. So my solution is going to be the ordered triple 2, 0, 3. Okay? And I can check this against every equation just to show you that it actually works here, right? Go up to the top. 4 times 2 is 8. 0 minus 3. 8 minus 3 is 5. 2 plus 0 minus 3. 2 minus 3 is negative 1. 2 times 2 is 4. Minus 2 times 0 is 0. Minus 2 times 3 is 6. 4 minus 6 is negative 2. So you can see it satisfies all three equations. All right. Now there's one more thing I need you to know how to do. We're not going to get to it this year. It's supposed to be next week's lesson. And that's how to set up a matrix equation. All right. So we're going to take a look here. One more example. I'm going to do 3 variables. You can do this with 2 variables. You can do it with any number of variables, really. I'm going to use the exact same one we just looked at. We've got 4x minus 2y minus z equals 5. X plus 4y minus z equals negative 1. And then 2x minus 2y minus 2z equals negative 2. All right. Now we know a matrix is just a way to organize information, right? So we're just going to go ahead and organize this system of equations into what's called an augmented matrix, okay? So a matrix, right, it looks like this. All right. Now everything's lined up. I've got all my x's lined up. So I'm going to make an x column. I'm going to make a y column. I'm going to make a z column. And then on the other side of the equal sign, I'm going to make just my constant column. Okay? And that's essentially how it's going to work. Now I actually don't have to put in the variables. I just have to put in their coefficients. So this first equation, the coefficient of x is 4. The coefficient of y is negative 2. And the coefficient of z is negative 1. Now because this is an augmented matrix, there's actually a bar here. And the other side of that equal sign is 5. For the second equation, coefficient of x is 1. Coefficient of y is 4. Coefficient of z is negative 1. And over here we get negative 1. Coefficient of x is 2. Coefficient of y is negative 2. Coefficient of z is negative 2. And over here we get negative 2. So this is my augmented matrix that represents this system of equations. And likewise, I can do this backwards, just to show you one of those in 2 variables, right? I could also have here an augmented matrix in 2 variables. It's something like 3, negative 4, 2, 1, 7, 5, right? If I need to express this as a system, all right, what would that look like? Well, I know this first one's x, so it's just going to be 3x minus 4y equals 7. And the second one will be 2x plus y equals 5. Okay, so I can also go from matrix to system and system to matrix. There's some really cool stuff you're going to learn how to do with this in Algebra 2. I'm sorry I didn't get a chance to teach it to you next week because I love this stuff. I just want to say, God, it's the end of the year. So I usually tell all my students this, and I feel like I should tell you guys the same thing. Reflecting on the year, I just want to tell you guys how much I hated it. I absolutely hated my time with you guys, and I'll be honest, I just passed most of you so I wouldn't have to see you again. That said, when you get to Algebra 2, please do not come to me for help at all. I have zero interest in helping you. So please, please, please just stay away from me for the rest of your life. All right. For those of you who haven't picked up on the fact that I'm very sarcastic, I'm obviously kidding. I've thoroughly enjoyed this year with you guys. And as you do move forward in math class, please know that I'm happy to help you with anything you guys encounter. I love Algebra 2. I love you guys. So if you want help, please don't be a stranger. Come find me, and I'll be happy to help. Hope you guys enjoy your summer, regardless of how it goes with the lockdown and the pandemic. And I look forward to seeing you guys next year, even though it won't be in my class. All right. Take care. Bye.